Kharkiv National University of Radio Electronics, and their group of researchers presents the paper titled Ukrainian Use Corpus as Text Classification Benchmark. So, Oleksii, please, the floor is yours.
Thank you, Oleksii. I would like to present my paper, Ukrainian Use Corpus as Text Classification Benchmark. I am Associate Professor of Software Engineering Department of Kharkiv National University of Radio Electronics. And my research interest is multimodal data analysis. Usually it's text, images, but my interest in merge this information. And I am member of Cost Action of European Commission, multi-generation, multitask, multilingual and multimodal language generation. And it provides me a lot of sources and networking for my research interest. And at the same time, I am coordinator of Tech Talents educational project in Kharkiv. We provide a lot of opportunity for students of Kharkiv University, and we provide him extra courses. And last year we have courses computer vision and natural language processing, and final exam we offer to contest on Cadre. It was amazing event. It takes 11 days. Students from our educational project make about 200 submissions, and there was idea to separate natural language processing problems in other direction and prepare a paper for this workshop. Objectives of our paper: create Ukrainian language dataset, critical problem of low resource language such as Ukraine is lack of unlabeled dataset for pre-training of word embedding or large data deep learning model, and the labeled dataset for benchmarking existing methods. And we need to improve quality of language, and we want to create this dataset. And the second part of our paper is benchmarked transformers models on created dataset. Each kind of sources for our dataset. We download news from famous Ukrainian news sites. It's 7 sites, and we try to download news for last couple years. It's about some less 100,000 text worth. And we should prepare data for dataset. First of all, we remove white space, we remove incorrect symbols. The next, we should to remove some information which can help which will be data leakage. For example, some news sites write this news. You can download this news from, and after that, source of the site. And we replace this text because it helps our students and our classifier to memorize site, not generalize this information. After that, we remove all duplicate of news. For example, daily publication about COVID statistic, about type of zone of different regions. All this information effect on memorize classifier, not generalize. After that, we clear on non-Ukrainian language pages. We remove English pages, pages on Russian language, because we want to compare our models only on Ukrainian text. And other data leakage is sure. And as a result, we have dataset which consists about 82,000 text. About 12,000 text will be removed from various reasons. And we split our dataset in train set 57,000 and test set 24,000 samples. And all subsets and train and test have a similar variable distribution. And the interesting fact, we different safe title and text, and we compare word in title and very popular length of title 10 plus minus 1 words, and very popular length of news less 200 words, it's about 40%, and less 400 words, it's about 60%. And for our benchmarking, we should use metric. Our dataset classes are unbalanced. It's real practice and word. So we need to use metric which will be. We use macro average F1 score matrix, which is resistive for unbalanced classes. And we should choose models for our benchmarking. First of all, we choose multilingual BERT. It was uncased and BERT-based model, not large-based. And one moment of this model, multilingual BERT model trained on a huge amount of data, multilingual data. There are about 108 or 4 languages. It's usually Wikipedia data, but last benchmark, multilingual BERT made on some dataset without Ukrainian language. So we should turn use that multilingual BERT train word embedding on Ukrainian dataset, but benchmarking model without Ukrainian language. It's some restriction for this model. Next, Slavic BERT. It's MBERT-based model, which trained on some Slavic corpora, but there are no Ukrainian corpus. So they probably, I guess that Slavic BERT should generate some Slavic morpheme or other idea, but Slavic BERT not adopted for Ukrainian language. The next model is Ukrainian Berta. It's Ukrainian Roberta. It's model trained on Ukrainian Wikipedia and Ukrainian Oscar part of Ukrainian Oscar dataset. The next model, Ukrainian Electra. We think that Electra model provides some better result compared with Roberta. Probably Ukrainian Electra will be the same compared with Roberta. And the last XML Roberta-based model, it's a model which trained the same way as multilingual BERT, but it uses large architecture, and it has more embedded layers. Okay, let's go. Pipeline of our experiment. We try to benchmarking our model on two parts of datasets. 10% of full datasets. It's a real situation in production when we don't have a lot of sources to train model on big dataset, or when we don't have a lot of sources for labeled big dataset. So we can try on a small part of full dataset, and we should understand what kind of result we have. And second experiment we make on full dataset. And we train our model on title, on full text. And we compare our model in the same train condition. The same number of training steps, the same computation time, and the same hyperparameters. And we have the next result. So we can see on this table 6 model, 5 transformer model, and first line it's baseline TDF, ADF bag of words and SVM classifier. So classifier, and we will compare this baseline with our model, and we can see 4 columns, and there are different types, different part of dataset. First result, we can see that XML-R model provides the best result on a long test when we work with full text of news. And but we should to remember that this model is large and require more resources compared with other transformer models. The next result, Roberta provide best performance for short text. So if we try to classify source of news only based on short text, on short part of that set, it provides better result. The next, we want to compare multilingual BERT and Roberta. Roberta provide each time better result compared with multilingual Roberta. 5% for short text and 36% for long text. And the next, we should compare Roberta and Electra. For short text, Roberta provides better result, but for long text, Electra provides better result. So we can see an area of for each of model, and we can see that Slavic BERT don't have significant performance compared with multilingual BERT, and Slavic BERT have the same result as multilingual BERT and don't have any opportunity for Ukrainian language if we want in future to use. And interesting result, simple baseline. It's linear SVM classifier based on bag of the word on long text, provide result not much worse compared with XML model. but we should to understand that SVM classifier require about 50 minutes to train. So the main results of the slide in future, if we need to make fast result and compare and make fast exploratory data analysis, we can use this approach. All this result we can see on this conclusion slide. Reference on our conference and contest on Kaggle. And thank you for your attention.
Thank you, Oleksii, for the presentation. And it was, I like that you prepared this data set and published it for public use. Really great effort. So while we're waiting for the questions from the audience, oh yes, Oleksii, but if you don't mind, I will jump in. So we have 3 Oleksiis here in the conversation. So my question is about those results. So can you please jump back to the table with the main results? Yeah, this one. And I'm curious. So your main task is to classify the source of the news article, and
yes.
have you tried to interpret how the model works? I mean, you take the article text, and whether there are any keywords that are crucial for the model to understand what are the source of this news article. For instance, you have this Ukrainska Pravda, right? And probably when you're dealing with the long text, because we see that the results for the longer text are much better than for the shorter text. So probably there could be some crucial keywords in the text that mark the specific source. For instance, somewhere in the text you see the mention of, for instance, the source, like Ukrainska Pravda or Новое Время, something like this. So have you tried to find out what are the main sources for the model of how they make such decisions?
Thank you for the question. I split your question into parts. First of all, interpretation of transformer model. It's very challenging problem, and it's very popular problem when our transformer makes a decision. We can try to which layers of transformer provide this information, and I work with this task, and I compare with other language. If we see how to transformer work with an English language, German, it works with whole words. For Ukrainian language, it works with parts of words. I don't know why it problem addressed to word embedding of transformer. So I tried to interpret how to transformer found decision, but it's I don't found significant result. Second part about stock words in news. This problem we start to solve when we try to find data leakage, and we create TDF matrix of bag of word, and we make He quadrat for different words, for different news, and we analyze the top 20 of these words. And if we see that these words provide information about news, for example, some news agency finished news details you can see download from this site. We all the sentence removed and replaced with sources. If we found some words, for example, some words which use after, for example, if he started description of images, I don't remember sentence of words, but we sometimes found this example. We left it. So maybe some features of authors, yes, we sometimes we see these features. So some news agency and some authors have some style, and this order of sentence can show what is the news.
Yeah, I see. So the authors also could be a significant feature. Thank you. And Oleksii, so please go ahead.
Yeah, I have read in your paper that XLMR here, it has a significant computational advantage over other algorithms. So taking this into account, we can say that maybe Roberta is like have a significantly better performance, because if you can provide more resources, maybe it will outperform XLM.
Thank you for the question. Really, we compare some different types of model because XLMR model required and 3 times more sources. The main idea to compare what price we pay for this significant result. So if we compare long text and large training set, we Roberta have result in one divided 100. So it's a very small difference for large difference of model. Yes, you're right.
Thank you. So seems we don't have any other questions. Okay, so Lydia, please. Thank you.
Hello, thank you for presentation. And if I am right understand, you're classifying news on some terms. I right understand? And which terms you use, and which keywords you use for determine them?
Lydia, thank you for the question. In our solution, I don't make any preparation of dataset before transformer. So I use full text or title for input to transformer, and transformer based model yourself try to found keywords or key part of words to generalize it and make and classify text. So I don't do any preprocessing of data for classifier.
Okay, you don't have some terms, you just classify all text.
Yes,
on different clusters. Yes.
And 7 sources of news. And
if I may, they classify. Yeah, sorry, Oleksii, please.
I would like to add that when I try to analyze word embedding of transformer, it don't use whole of words. It use part of words. So we cannot say about terms, about sequence of words, about bag of words. Transformer work in some different way.
Okay, thank you.
Thank you.
Yeah, so I just want to add, Lydia, that the goal of the paper was to classify based on the source of the paper, like news agency, not on the topic or any other means. Artem, please, do you have a question?
Yeah, thank you. Thank you, Oleksii, for your interesting report and for your data set. And I'd like just to ask if your data set contains original versions of documents or it somehow changed.
Our datasets have original text with removing some parts of this text. For example, spaces or wrong symbols or some information which is data leakage, which help to classify news with some wrong features.
Yeah, but why I'm asking because
yes.
I was presented the previous presentation, and my model was trained on news exactly and on the news portal Ukrainska Pravda. So maybe we can utilize, if you say that this data set contains the original versions, we can even try to apply this model in order to build to project sentence representation into two-dimensional space in order to compare the retrieved clusters for Ukrainska Pravda, for other news article, and to reveal the dependency between sentences for each source. Maybe it will be useful later to for other tasks. As I understand, you may utilize your model for the faithfulness checking in order to understand whether this news portal provides true news or false news and so on. So thank you for the data set. I suppose that it will be really useful for the investigation and for me as well. Yes, thank you.
Thank you. It will be very good if you can use this data set for your task.
Yeah,
thank you.
So thank you, colleagues, for finding this opportunity to collaborate. At least we have one outcome, positive outcome from our workshop in terms of collaboration between different research groups. So probably, Artem, you can come next year with the results trained based on Oleksii's group data set.
Yeah, of course.
Okay, thank you so much, dear colleagues. We run out of time. So let's conclude and finish our first Ukrainian natural language processing workshop hosted by ICTERI conference. It was our pleasure to have you here to listen to your presentations. We have different kind of topics from different perspectives, and I believe that next year we will see you again with next steps in your research, or probably from totally different perspective. Also, we encourage others who listen to our workshop to submit your research and to join our community of researchers working on Ukrainian NLP domain. For me, it was a pleasure to have international representation here. We have researchers not only from Ukraine, but for instance, from Germany as well, and our keynote speaker from Ireland. So I think, and probably Oleksii Ignatenko will also commit on that, it was a good first success. As we said it in Ukrainian, not that glivki mlinets, right? So, I think, and I wish to all of us that next year we will have the whole day for our workshop loaded with interesting papers, and that will benefit for whole Ukrainian NLP community. Thank you again, and thank you, Vadim, for helping us to organize all this event, for supporting us through the whole process of preparation. Thank you so much.
Yeah, thank you.
Thank you for organization.
Thank you for organization.
Have a good one. Bye-bye.
Bye.
Bye.